So we are on page 59 in your packets. It says, we're talking about population here. In a recent year, the world population, sorry, this is driving me crazy. All right. Are we good? Chromebook should be closed, pencil should be out. We're on page 59. In a recent year, the world population was about 7,289,332,000. The population of the United States was about 3 times 10 to the 8th. About how many times larger was the world population than the population of the United States? Well, can we estimate this 7 billion as can we estimate this as 7 billion? Is that fair? That's reasonable, right? So if we have 7 billion, what would we then, how would we write 7 billion? 7 billion. How many place values are after the 7? 1, 2, 3, 4, 5, 6, 7, 8, 9. Excellent. So this is 7 times 10 to what? The 9th? We want to know how many times that is larger. Because we're not saying how much larger. If we were saying how much larger, we would say this minus that. But we're asking how many times larger. That's why we're dividing. So we're going to say 7 times 10 to the 9th divided by what? The bigger population divided by the United States, right? Remember, we're going to use the associative property and associate our numbers over here and then our powers over here. So 7 divided by 3. You may absolutely use your calculator. 7 divided by 3. It's 2.3 repeating. So 2 1/3. 2.3 repeating times 10 to what power? How do I figure out what power it is to? Well, our quotient of powers property says we take the top exponent minus the bottom. What's 9 minus 8? 1. So that is just 2.3 times 10. What's 2.3 times 10? 23. Yep. So it would actually be 23 1/3 repeating because this 3 goes on forever, right? Or about 23 times would be fine too. Oh my Lanta, this pencil. All right, questions about page 59, because this is how we're going to be figuring out these apply problems. Page 60 gives us a good check. Try it out. It says, in 2005, 8.1 times 10 to the 10th text messages were sent in the United States. In 2010, the number of annual text messages had risen to, so this is 1,000, million, billion, trillion. 1,810,000,000,000. About how many times as great was the number of text messages in 2010 than 2005? So which of these numbers is going on top of our fraction? The bigger divided by the smaller, right? So we need to write this in scientific notation and then divide it by this. And then simplify. Try it. You gotta be able to do this. All right, guys, if you're doing these, they should be fairly quick. How did you write this in scientific notation? Where did you put the decimal? After the first one, right? So 1.81 times 10 to how many zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, I'll double check. 1, 2, 3. Yes, 4 groups of 3 zeros there. But we had to move it over. Divided by 8.1 times 10 to the 10th. So first we're going to deal with those numbers. So I'm going to put that into my calculator. 1.81 divided by 8.1. So this is kind of an ugly number. Remember, this isn't necessarily going to be in scientific notation because our decimal point got moved. Times 10 to what power? We would say 12 minus 10, which is what? 2. So if I solve this, then I would just be moving this over 1, 2 places to get 22.3 times is great. Now, if you wanted to change this to a number and then say this divided by that standard form, would you still get 22.3? Yeah, so if you wanted to do it a different way, you could say 8.1 times 10 to the 10th, if you're not sure how to do this, but I recommend you practice moving it 10 places. Look, remember how we told you sometimes it will write it there? See how they wrote it in exponential form? Remember, we looked at this a little bit when we were looking at what a graphing calculator would look like. So what you can't see, it says times 10 really small right there. There, it's a little bit better. It won't focus. Okay. See where it says 8.1 and then there's a little times 10 as being raised to the 10th. That's the weird part. Now, I'm going to leave that as my answer, and I'm going to take the number that they gave us. So I'm going to start typing in that 1810. Sounds like I'm dialing a phone number. And then I'm going to add 369 more zeros. So I'm going to count to 9 while I'm putting in zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Divided by, and then I'm going to use my answer button right at the bottom. Let me zoom out sometimes. So I put in that new number divided by, I still had the number I just put in, divided by my answer, and that should come out 22.3. So it's okay if you change them back into standard form too. When is Veterans Day? Veterans Day? Yeah. November 7th? No. All right. Page 62. Page 62 is what you are going to be practicing now. So I don't know. I was thinking I would give you time to do this and then go over this today, and then time to do the practice quiz and then go over it tomorrow. Yeah. So I was thinking practice quiz tomorrow. Are you okay for that? Which would push the quiz to Thursday. Is that okay? You won't be too swirly by Thursday? We'll be okay there. So right now you're going to spend time completing 7 through 12. Really think about this, refer back to your examples. Be sure you know how to go back and forth from scientific notation to standard form. That's very crucial for your quiz and for understanding page 62 as well. All right, I'm going to pause this while you guys continue to work on it at a level 0. Make sure you're practicing them. Number 7, they're giving us the mass, guys. They're giving us the mass of 1 bacterium. After 30 hours, they're telling us how many bacterium there are, or bacteria rather there are. They want to know the mass of the new population. So for each of these is this amount, so we have to multiply. So if you want, you can say 2 times this times that, or you can change them both into scientific notation. So this would be 4.8 times 10 to what power? 1, 2, 3, 4, 5, 6, 7, 8. So this would be, well, 2 times 4.8 should be 9.6. Not 9.2, 9.6 times 10 to what power? What is negative 12 plus 8? Negative 1. So write your answer in scientific notation, then it's done. The other way that you could do that is to say 2 times 4, 8, 0, 1, 2, 3, 1, 2, 3, and all those zeros equals times 10 raised to the negative. See where I got that negative, not minus. Here, this negative sign, negative 12. And it gives you here, remember, this is why we learned how to read it from a calculator. It gives you 9.6 times 10 to the negative 4. It gives it to you in scientific notation. Okay. All right, move on through there, 8 through 12, keep working. So we have done 7 already. Number 8. At the beginning of the business day, a bank's vault held $575,900. By the end of the day, 3.5 times 10 to the third dollars had been added to the vault. How much money did the bank's vault hold at the end of the business day? So what are we doing with these two numbers? Adding them. So I would say that it's easier to just put them both into standard form. So you have 575,900 is where it started. How much is being added? So I would be moving this 1, 2, 3 places. 3,500, that's it. And then I would add them. You can use your calculator if you would like. I don't think it's necessary. So this is how much you, and it wants your answer in standard form, which is even better, right? We don't even have to change it. If you were changing it, just for practice sake, you would write 5.794 times 10 to what power, and you would count back 1, 2, 3, 4, 5. You're right, I wouldn't probably need scientific notation for that, which is, it's kind of funny that they wrote that in scientific notation. All right, explain how the product of powers and quotient of powers property help you to multiply and divide numbers in scientific notation. So you would multiply, so this is product, right? Or divide, this is quotient. So we would multiply or divide the first factor, or factors, we should say, right? Then we would either add the exponents on 10 if it was the product, or what would we do? Subtract top exponent minus bottom exponent for quotient. Make sure you know how to do this. Oops. I like this next real world. An Olympic sized swimming pool. I'll give you a second. Sorry, you're probably vigorously writing right now. Bless you. I'm gonna have to ask you. Sandra, are you talking to Xander Steve? Okay.
No, I think they're talking about feet. Not talking your feet. I'm pretty sure you're talking about feet. Thank you, the feet better.
All right.
Oh.
Okay, are you ready? An Olympic-sized swimming pool holds this many gallons of water. A standard garden hose can deliver 9 gallons of water per minute. If the garden hose was filling the pool 24 hours per day, how many days would it take to fill the Olympic-sized pool? Explain your reasoning. All right. So what I would do is I want minutes and I want to get rid of gallons of water. So I would write this as 6.6043 times 10 to the 5th. And I would write it over 1. This is gallons. And then I would be multiplying by, this is per minute. So I'm going to flip it around, say for every 1 minute, how many gallons will be filled? 9 gallons. This helps me to see what I'm actually going to be doing. This way I cancel out gallons and I'm left with what? Minutes. And that's what I want. I want time. So this times this is really just this, and this times this is really just this. So what is this really? This divided by 9. Does that make sense? So I might say 6.6043 times 10 to the 5th power, right? I'm gonna just put it into standard form now, is equal to this, and I'm dividing by what? 9. This gives me how many minutes? 73,381.1 repeating. Now, this is how many minutes, but I want to get rid of minutes. So I'm going to multiply it by how many minutes are in an hour. 60 minutes. So I'm going to really be dividing this by what? This is on top, this is on bottom. So I'm dividing this number by 60. So divided by 60 gives me 1,223 minutes. Is that helpful yet? Not really, I'm running out of room. Oh dear. I don't think so. I think I'm okay. All right, so 1,223 minutes. And how many minutes are in an hour? 60 minutes are in 1 hour. So now if I multiply, or in other words, divide by 60, I'm going to get how many hours? So divided by 60 again. Does that give me how many hours? 20.38 hours. But it wants to know how many days. So this divided by 24 hours would give us days. My goodness, so not even a whole day. I don't know why they wanted to know days. Is that what you guys got? Did I do something weird?
No, I got.
You got 50 days. Oh, look, this is what happened. This shouldn't have been minutes, should it? That should have been hours. That's why. This should have been hours. So I should have been dividing that by 24. So I'm going to multiply by 24. And then I'm going to multiply by 60. That takes us back to this 1223. And that's what I'm dividing by 24. I screwed that up royally. That's okay. I wasn't paying attention to my labels. I thought we still had to turn to hours when we already had. All right. So this is when we divide by 24. And it's about 51 days, I would say. All right. That was a lot of work. All right. Especially when I screwed it up. Find the error. Miguel found the quotient as this. So 5.78 divided by 0.12345 zeros and then a 2. So what did she do? Or he do? What did he do? Instead of finding times 10 to the 5th, he found times 10 to the negative 5th. He went this way. Right? Because when we put into our calculator, this divided by that, we get this, but then we need to multiply by 10 to the 5th, and it looks like he did it times 10 to something else. What did he do? Or maybe he wrote them out. Maybe he said 5.78 times 10 to the 5th divided by 2 times 10 to the negative 1, 2, 3, 4, 5, 6. So 5.78 divided by 2 is 2.89. And we have to say top. Oh, this is the negative 6. That's what he did wrong. So this is 2.89 times 10 to the 5 minus a negative 6. He just said 5 minus 6. He didn't subtract the negative. Really, boy. So that we would correct it. It should be 2.89 times 10 to the 11. Not to the negative first, like he found. All right, a googol is the number 1 followed by 100 zeros. Earth's mass is this. How many Earths are needed to find a total mass of 1 googol kilograms? So 1 followed by 100 zeros. This is 1 times 10 to the 100. Divided by 5.972 times 10 to the 24. So 1 divided by this, 1 divided by 5.972. So we really are going to move this over 1, which means we're going to subtract 1 from our tens. So 0.17 times 10 to what? What's 100 minus 24? 86. But then to move it this way, we're gonna subtract 1 there. Did you get 1.7 times 10 to the 85th? Yeah, I know that. That one was a little tricky too. All right, You have about 10 minutes to be working in Alex for the remainder of the hour. So be sure you get at least one topic done today.